Hey, what's up, folks? Welcome back to another 3D Hangouts. My name is Noel Ruiz. I'm a designer here at Adafruit. Joining me every week is my brother Pedro.
Good morning, everybody. I'm Pedro, Creative Tech here at Adafruit, and every week we're here to share 3D printed projects featuring electronics from Adafruit.
That's right. This is a show where we combine 3D printing and DIY electronics to make inspirational projects. Hello, everybody. We are hanging out in the Discord chat room. If you would like to join us during the show, you can head on over to discord.gg/Adafruit. We are hanging out in the live broadcast chat room, and we'll take a moment here to welcome everybody who's joining us live this lovely morning.
Good morning to everybody hanging out. Just jumping into the chats. We are on Discord, on YouTube, Facebook, Periscope, and Twitch. Going out, shout out to everybody hanging out. Good morning, Roofs, DJ Devin, Yoshi,
hello,
Andy Calloway. Good morning,
Hola.
Good morning.
Yeah, we're hanging out here, and we got some fun projects to share, some shop talk, lots of community makes, and some, of course, prototyping, what we're working on for future lovely projects. So I'm going to start off with doing the housekeeping. Let's go ahead and jump over to adafruit.com/free. If you spend more money with Adafruit, you're going to get some free things. We have a couple different tiers. The more money that you spend, the more things you'll get for free. Let's start off with $99 or more. If you order $99 or more in your order, you will get a free half-size PermaProto. That's that lovely PermaProto PCB. That's great for permanently bonding your components for making projects. For orders that are $149 or more, you're going to get a lovely dev board. That's the KB2040. That's a lovely RP2040 based microcontroller that has awesome features like a STEMMA-QT port, and it runs with both Arduino and CircuitPython. If you spend $200 or more, you'll get the KB2040 dev board, the half-size PermaProto, and free ground shipping from UPS for continental US only. And then the last tier, at a whopping $299, if you spend $299 or more, you'll get the free ground shipping from UPS, the KB2040 dev board, half-size PermaProto, and a BBC Microbit V2. All that is available on adafruit.com/free while supplies last. So head over there if you want that. Next up, we'll take a look at the jobs board. If you are in the market for a new job, or if you're looking for folks to help you out with your projects, you can post it up on the jobs board. And that's a free website for makers, engineers, artists, designers, what have you. It's all free and available for people. So check that out at jobs.adafruit.com. All right, let's head on over to the Discord. And the last piece is use a 10% off coupon code. This week we have a coupon code. It's TFT stand, and you'll see why in a couple of moments. But if you are getting stuff, add them to your shopping cart. This coupon code will work for all physical goods. And that is our housekeeping.
Excellent. Adding all the links here. Cool. Let's go ahead and jump into this week's super useful project.
Okay. Let's see. Let me hide your screen here, and then I will add. Sorry, I will add my screen, and then we'll do one of these dealies here. And then I'll hide for a second. Bring myself. Hold on, I'm almost there, folks. There we go. I got it. We have to like shuffle cards around. Yeah. So this is this week's project. We wanted to do a simple 3D printed stand for Lamar's new Feather. This is the Feather ESP32-S2 with a reverse TFT. You have seen a Feather with a built-in TFT, but this time it is on the back of the board. So we figured we should make a little 3D printed stand like we normally do, but design it specifically to house the new ESP32-S2 with the reverse TFT. So you got a couple different buttons here. You got your display here. You have the reset button. And then it is an ESP32 based chip. So that's the Espressive chipset. And this is the S2. You get a lot of the features that you know and love about a Feather. You get onboard battery monitor onboard LiPo battery charging. You have the USB-C connector, and you have the Stemma QT breakout. This particular one, I think you have 4 megabytes of SPI flash, which works great with CircuitPython. So you can have audio clips, libraries, fonts, all that sort of stuff. And you have a built-in NeoPixel, which is firing off right there in the rainbow mode. So our 3D printed stand, you secure it with these M2.5 and M2 screws. We'll talk about that a little bit later, but I'm actually running a project from Liz Clark with City DIY. She came up with a really cool Octoprint controller / monitor. We talked about this on last week's show, but now her Learn Guide is public, and I am running that software. It allows you to preview the status of your Octoprint monitor. So here you can see I'm printing something right now. It uses Adafruit IO and MQTT to send and receive commands. So right now I'm receiving the status, and we're using CircuitPython. And CircuitPython is using it's using that built-in progress bar. So you can display a progress bar status. You can display bitmaps like the little icon here of the Octoprint mascot. And then you have some controls here. So you can use these user buttons to do some things. I'm not going to do it because I can either cancel my print, resume the print, or pause the print. And I don't want to do that right now, but hey, it's going good. And then you get the NeoPixel, which is built in to the Feather. And right now it's programmed to just display the rainbow while it's printing. And when it's done printing, I have it set up to do a pulse. So it pulsates. But since it's CircuitPython, you can easily go in there and add features. Maybe you want to add a speaker and some audio playback so that when your print is done or when your print is paused, you can have it display a nice sound effect, a chime, a screaming goat, whatever you want, which is really nice. And I really like the user buttons here. These are actually a little bit different buttons than what you've known. They have like a little bit bigger actuator. It's kind of neat.
Easier to press.
Yeah, it's easy to press. And then 3D printed stand has just a big opening here. It prints on its side like this. It gives you a 70-degree angle, so it's like not straight up, but it gives you like a little jaunty angle for viewing. And then you have access here to the Stemma QT port, the JST connector for battery if you want to make this portable. And then you also have the NeoPixel, which shines through, and it kind of illuminates the back of this stand nicely. The stand prints without any supports. You'll just want to use a brim when you it's oriented like that. Imagine this is the surface of the bed of the 3D printer, and it just prints upright. And then the holes are a little bit peculiar. So if you've used the Feather before, you'll know that the standard mounting hole size is an M2.5. But because the chip is kind of chonky, the ESP32-S2 chip, we're kind of limited in space. So we ended up using M2 hardware. So these two mounting holes are M2 screws, and these are M2 sized standoffs. They're black nylon, which is great because it's not going to short anything out. But the length of them are about 10 millimeters long. Both of these are 10 millimeters long. So we don't stock the M2 hardware, but you can get that off Amazon or another store. But we do stock the M2.5. Hopefully one day we'll stock some M2 hardware because it's becoming more and more prevalent with these ESP chips. We're running out of clearance on our mounting holes, but hey, it's nice that you can use both here. So that's kind of the whole thing here. We do have the CAD files available on the Learn Guide, and then we'll kind of run through both of the guides. So let me do that right now. Let's see here. All right, let me hide that screen, and there it is. All right. So if you go on to learn.adafruit.com, you'll see that this guide is now public. I have a couple of parts here listed. We are currently out of stock of the TFT Feather, but we are definitely going to have some
in stock.
I know. They go out pretty quick. Very popular.
I had it in my cart. No.
But did you? Oh, and you didn't check out.
It.
Wow.
No, I didn't check out. What the heck?
I'll tell you after the show. you can still get one. You just have to email our support team and let them know. we have a special stock for employees because we got to make projects with them.
It should show you that. Don't leave things in your cart. It was listed on the S3 Feather I had in there. I'm like, I'll check out after the show.
Oh, the S3,
no.
No. Yeah.
Now I can't,
well, we do have these cables. We do have cables in stock. These are those magnetic tips. So you get USB Type-C, Micro B, and then iOS cable tip. And it comes with 3 of them. And they're woven. They're very nice, high-quality USB cables that have data. And they have these built-in LEDs to let you know that they're working. They're really nice. And they come in 2 different sizes. We have a 1 meter long and a 2 meter long. Of course, we have the black nylon standoff kit. It comes with screws and standoffs. These are the M2.5. And then for the M2 hardware, I have something linked here from Amazon. You could find your own, but I tend to get this kit here. It comes with just about all of the sizes of screws that you need, standoffs. And I like this kit particularly because it actually labels them on their little tackle box here that it comes with, which is nice. So check that out if you want to get some M2 nylon hardware. I got a page here for the assembly. It's pretty simple. You want to finger tighten your things because it's nylon. You don't want to strip the screws. So you want to install the standoffs onto the Feather first. And you'll notice that it's on the front of the Feather. Remember, this is the reverse TFT. And people may be wondering, what is a reverse TFT? It just means that it's on the reverse side of the Feather. You might have seen our earlier Feather, and it's just on the front side instead of the back side. So that's how that's working. Once you have your standoffs installed, you just want to align the standoffs with the mounting holes on the stand, which is fairly easy to do so. And then just use your screwdriver to fasten those other screws into the standoff so it's mounted in place. It is reversible, so you can have your USB cable go on the left or the right side. I chose to have it on the left side. So that's pretty much it there. You can provide USB power to it using a 5-volt USB hub or your computer's hub. CAD files are available. I got a little animation here that shows how the screws and the standoffs are all working together. It's pretty simple. You'll want a build volume that's at least 50 by 50 by 68 millimeters on the Z. So that means you could print this on those really small, maybe you have a resin printer. Those small resin printers have small beds typically. So it'll work on those. And then you'll just want to have a brim if you're using FDM printer. So I have here a brim. It's about 8 perimeters wide, or you could use mouse ears, whatever you prefer. I like using a brim just because it's going to make sure that the entirety of the perimeter of the part is going to be nicely adhered to the bed of the 3D printer. We have a step file. In the Fusion 360 files are available in this download button here. This is download CAD source. And then we also have a link here to the TFT, the Feather TFT. We have a 3D model of that available as a step, as a STL, and as a Fusion 360. It has all the onboard components like the display, the buttons, the connectors, and all that stuff, which is really nice. And it's on GitHub, so you can download it and do all that fun stuff. It prints as is. You don't need any support material. Just want to have that brim. And that is the guide for the stand. Next up, I'm going to switch on over to Liz Clark's guide on the Octoprint monitor using CircuitPython and the Octoprint software. So definitely read through it. If you have Octoprint installed, you're already halfway there. You do want to have your Octoprint set up first. So this kind of tells you that you need to have that set up. And then some of the parts here, of course, the Feather that we use, some of the standoffs. So she 3D printed and designed her own case, which I actually have right here. Let me see if I can switch over to my thing. So, I removed it. Let me bring it back.
Oh, dang it. I removed it.
I know. We'll just have it like that. That's fine. So this is my stand. This is Liz's case. So it also uses M2.5 and M2 hardware. Yeah, I know, right? And it's in the shape of an octopus. So it has this kind of tentacle stand. Yeah, I know you're clicking through all of them, which one? And then we can remove. Then we can add our sounds.
No, I wanted to have.
There it is. There you go. I got it. So let me Yeah, so let me just give a quick look at it. So yeah, it's got this this front faceplate, this bottom piece here that gets secured with an M3 screw and a hex nut, and then it's a snap fit bit. It's got a chunky back here because she wanted to be able to house a bigger battery, so you can actually house a battery, and it has an opening here for the USB-C port. So it uses the snap fit features. So this comes off. This is where the Feather actually gets mounted to, with screws and hex nuts here. So it's, the faceplate has really nice cutout to use the TFT model that we set up to make these, like, look how perfectly accurate these cutouts are for the buttons. It's a really good way to do it. And it exposes the entirety of the display. Oh yeah. And then you have some features here, like the eyes, supposed to be the octopus's head. And then these are those snap fit edges here that you know about. And then this is the other side. So you can house a battery in here. Or you can have it as a, you could take this base off if you wanted to and have it as a case, but it's cool that it has the octopus tentacles here, the 8 tentacles. And that's kind of it, really. So it snap fits, it's all cool. She was doing some testing on it, so I think the software might just be the standard thing. So I'll just leave it there. You can imagine it working. Yeah, so there's that. And let me switch back over to, sorry, switch back over here to the Learn Guide so we can quickly look through it. So this will run you through all the parts you need, and it uses Adafruit.io, so you can use the free account for this one. Or if you have some other devices, you'll just want to like readjust your device. So that's using the TFT Feather. You can download the parts here for the case, which is here in the 3D printing part. So it walks you through step by step kind of what you need to set up. So first of all, you need to set up your Octoprint. So it uses the MQTT plugin. So you'll want to grab that. This walks you through installing the plugin and setting it up. So you just want to set that up in your Octoprint kind of instance that you have running on your Raspberry Pi. Most likely you're using a Raspberry Pi in your 3D printer. And then the next one shows you setting up the actual plugin. So it's just making sure that you have, oh, you need a second one. You need the MQTT subscribe plugin. So you actually need 2 of them. Fair enough. Then you want to configure it. So this is where you kind of add those, all the bits that you need. You rarely want to follow this to the T because it really requires these specific ports. So on port 8883, you want to have that set up, and you want to use the protocol version MQTT v33. She went through a lot of trial and error to get this to work, and this is like the only way to get it to work. So you just have to have the right port number and the right version of MQTT. Luckily, it works. You'll want to use your Adafruit.io username and your Adafruit.io password key. So you want to make sure that you have your own stuff set up. And then this is going to walk you through some other stuff like setting up the all of the kind of nitty gritty details that you need for setting up your MQTT feeds. So your feeds event, and yeah, so just run through that, and then you'll get your feeds will start pulling in to your feeds dashboard in your Adafruit.io account. So just kind of follow all that. Next up, you're gonna set up the MQTT subscribe plugin. So just follow all of this stuff. Here's a nice table of all of the kind of values that you want to add in those text fields. This is for rebooting Octoprint. This is for the preheat the printer. If you want to update these values, you can totally do that. You can have it be a different value for heating up. Maybe you want to heat it up to 220 or 215, whatever. You'll just want to make sure here. Or maybe you want to heat up the bed. In that case, you would want to use a different, instead of tool 0, you'd probably use like bed. But it all depends on your printer. So this is just kind of here as a placeholder for folks to get started with. Here's how to cool down the printer. You're telling the tool 0 to go to 0, 0C. Here's how to pause the print. Here's how to resume the print. Here's how to cancel the print. So that's all there for you. Next up, we walk through installing CircuitPython on the Feather TFT itself. Pretty straightforward. You double tap the reset button, then you drag and drop the UF2 file. This is running the latest version of CircuitPython, which is 8. So CircuitPython 8 is the latest version right now. And then you want to set up your settings.toml file. So this is a dummy file, but you want to replace these with your Wi-Fi SSID. That's the name of your Wi-Fi network, password of your Wi-Fi, and then here are like the port and the password for your API thing that you get from your Adafruit.io account. Some more setup here. Yep. We're just kind of running through, and then here's a quick test to make sure that you are running your settings.toml file correctly. And then we're on to the code for the Feather TFT. Liz did a great job of breaking it down, so you'll want to run through it. It's using display.io. So if you've used display.io before, you'll know how to change up the fonts if you want to use different fonts. If you want to use different bitmaps, you can do that as well. You can use the rectangle or the rect shape objects to create your own shapes. So if you want to create a different interface, you can do that. All the button setups are here written out for you. The NeoPixel object, you can change the brightness. You can control a longer strip of NeoPixels if you wanted to, just by kind of updating these values, which is really cool. And then all of the kind of nitty gritty stuff that you need for getting your feeds all set up. It's all there for you. Some of the printer state options are here as well. Different colors for the NeoPixels, and clock is most likely how much the delay. So it's checking every 5 minutes or so. These are the NeoPixel animations that we're using, Rainbow and Blink. I'm using Pulse, but you could use any other number of LED animations using the LED animation library. And then here's the logic. It's all broken down there. And I think if you scroll down here, you can see more of how your CircuitPython drive, your USB drive, is supposed to look like. And then this breaks down how the code is working, some of the display attributes, the pixel, the button, the feeds, the loop. This is a really good kind of how to use MQTT to kind of both send and receive stuff, and how to ping things back and forth. So really, really top-notch Adafruit.io project. And then onto the assembly page, just kind of shows you how to set up the case. How do you want to use the hardware we talked about already. And then the usage page shows you how to use it. So these are some nice GIFs of like canceling a print, starting a print, preheating a print, all that stuff that it does. So yeah, that is the project in a nutshell. Very, very cool project, very useful. Another thing to note is like you can take this project on the go, connect it to a different Wi-Fi account, and then you can access your printer from afar, which is another kind of cool feature.
So cool.
Let me plug in my instance here and see if it's see if we you can see how it boots up. It's going to say it's looking for the IP address. Once it finds it, it starts connecting. So it shows you that it's connecting now. You get this nice NeoPixel green color. It's all in the code. You can adjust that if you'd like. Once it connects to the server, it'll tell you, oh, look at that. It's 99%. And then it's running that rainbow animation here. And when it's done, it'll start a different animation, and it'll display the text here that it's complete, which is very, very cool. But you could also display, you know, the heat, the nozzle temperature, and the bed temperature. You could go all crazy. I envision this like expanding this out to like a PyPortal. Adafruit's PyPortal has a bigger display. That way you can display more things. And it just finished. It's actually pink. You can see here that the NeoPixel is pulsating. I actually changed it on my own. I wanted the pulsate instead of the blink. And then you can see you can change all the graphics. You can make it do audio if you'd like. So it's a good starting point for folks to get started with. There's a confirm button here, and this will just let you know that the status is operational. So at this point in the code, you can now send commands to your printer through the Octoprint interface. So I can reboot, heat it up, or cool it down. And right now it's cooling down. So yeah, it's what timing? Like that's an impeccable timing, dude. Like it's perfect, right? Like the print just finished. And then I could share here my Octoprint itself. Let me see if I can drag and drop these tabs. All right. So there is my Octoprint instance.
Very cool.
I can control it here, I think, right? I'm trying to move the bed here with the onboard command keys here. That's just a part of the Octoprint interface that you can do. And this segues into the prototyping, I guess. I got this 3D printed snap fit case for PyPortal. So we can do that, or we can take questions. Do we have any questions?
Let's see.
Here.
Some ideas from Yanni saying that one of the squid arms can be used for a USB connection. One could be for buttons. It's a good idea.
Pop, pop, pop. Yeah, they can be touched too. That'd be fun. You can do so many different things with this. Yeah, for sure.
And then Badaddy is asking why are buttons D1 and D2, why they pulled downs on the reverse TFT board. I could have swore I heard Lamar mention something about this. There's a reason behind it.
That's a good question for Ask an Engineer tonight. I'm not sure exactly why Lamar made that choice.
There was this, the chip or something like wants it is reversed or something, or wants it that way or something. Some one of the parts. It's how it does it instead of the other way around.
Oh. Okay, fair enough.
Then,
that's more of an engineer question for Lady Ada herself. We don't know.
I'm gonna guess she talked about it like when she was looking for the DigiKey search. I feel that's where I remember hearing something about that.
Okay.
And just some nice banter on throughout what we were talking. So definitely check it out on discord.gg/Adafruit.
Okay. If you want to pick up anything for your project from the Adafruit shop, you can use our coupon code. Don't forget, DFT stand. It'll get you 10% off your order. Just throwing that out there as we have a little break here.
Yep. Remember, don't leave things in your cart. I'm sitting here refreshing. Yeah. It's gone.
I got a comment here from Twitch saying, look at Octodash. Have you heard of Octodash, Pedro?
I have not.
I've not heard of Octodash.
I was actually wondering
we'll take
how
a look
you
at
got the full screen to go on there.
Oh,
so
yeah.
Do that with mine. That was just, all I could do was like expand it or the font size inside of the browser.
Yeah, I can show you how. Under the icon here, we'll go to plugins, plugin manager, and I have this thing called the full screen plugin from Paul V. Vires. So it's just an extra plugin. The plugin community for Octoprint is so amazing.
It's huge. It's so big that you have to have like a blacklist on there. So you don't get any nefarious ones.
Really? Okay. Yeah, so that's the full screen plugin. It just lets you double click on your webcam monitor and it just makes it full screen. That's all it does, and it's really nice. And then you can see here I have these other two, and then I have Octolapse. And then you might be wondering, well, how do you have that black theme, the dark theme? It's called Themify. It's another plugin. I really like the dark theme. It's not default to Octoprint, so I have Themify plugged in. So I guess we could go to get more, and we can look for Octodash.
Okay, that's where it is, yeah.
Octodash.
You
can go to its homepage here.
I can't install because I'm using my instance right now.
Oh, really? Gotcha.
Yeah.
I'll look more into it, but it looks like it lets you do like some graphical interface stuff for creating your own kind of dashboard.
Icons, yeah.
So that's neat.
Okay.
Yeah. You can upload a custom theme from it, looks like. Cool. Very cool.
It's like something to send Tyler to, huh?
Yeah. Let's see what the details is. Yeah. So it just kind of lets you have icons and things, I think. Cool. Yeah, we'll check it out. Yeah. It has turned into the Octoprint show. Very fun, yeah. I also am really digging Octolapse. That's what you use, Pedro.
Good. Yeah,
it's very, very good. It gives you so much control over your time lapses. So, yeah, it's really great.
There was a lot of code that needed to be written to even get this to work, but now you're just telling it park over here, take a snapshot here, wait for this long.
Yeah, I have more tests to do. But let me see if I can pull up a little video. I shared a video on my Mastodon account where it shows my case actually 3D printing. Let me see if I can go to videos and images. You can't preview it here, but I could, I guess, play it. But yeah, I was able to get Yeah, it downloads as MP4. I'll share it later, but I shared it on my social account. It looks really cool. It just looks like it's growing.
Yeah, I got to remember to go through all mine and actually delete because they start piling up.
Oh, they do. That is a fun.
Yeah.
Yep.
Oh yeah.
You
Like
have
how
like
it
a whole
tells you
slew
to
of
failed.
them. Oh yeah, and it tells you if they failed or not, which is great.
Uh-huh.
Yeah. Yeah.
Is it?
Very cool.
Oh, there is a preview, dude.
Yeah. How?
Yeah, I'm showing it. Let's switch to mine.
Oh, that's fantastic. And this is using the webcam that's built in. So you actually have two cameras on your setup. You have a DSLR Canon 5D, and then you have your USB webcam. I'm just using a USB webcam. It's the easiest.
That's cool.
That's great.
It does have sort of a. Let's look at this fail.
Oh. Yeah, let's see some fails.
There he goes.
Blah, 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 blah. It starts moving and growing into spaghetti.
Yeah.
That's fun. That's really great.
Already here. Let's go ahead and look at what I'm prototyping. It's printing.
There you go. Yeah, that's funny. You'll want to get that full screen plugin after the show because you can't install plugins while you're printing.
Yeah, it's the best I can do.
It's the best I can do.
We've got our so we're prototyping. What are we prototyping? So this week's what are we prototyping? We got our preview pass thing for Tron Light Cycle. So of course we're gonna do Tron project now. The Tron identity disks, as I think it's been done to death, but now it's super easy with CircuitPython and being able to drag and drop MP3s on there. It's like the easiest thing to do on there. And with the prop maker wing, you can have like the accelerometer, based on how you're moving the disk, it can make different sound effects. So that's all cool. The thing that we haven't seen anybody do for the identity disks is actually having magnets on there and having it attached to your back, which is like the thing that always happens in the movies.
Yeah.
So iconic that, my 9-year-old who has not sat down and watched the full Tron knows dang well that disc goes onto the back of your back. So that's what we're going to do with these. Make an identity disc with some magnets so you can actually stick it to your back. All the other stuff is now considered easy with CircuitPython. So it's like, oh, okay, cool. Yeah, it lights up. Yeah, it makes sound effects. Cool. It has the motion control. Cool. And it also sticks to your back. What? So we've been looking at some of the preview photos that you can get while you're on the ride. And it looks like there's a couple different versions. Obviously, you're not going to be able to keep that thing. Of course, you could buy one out of the gift shop. I'm sure they're going to have those back out. But it's probably not going to have that magnetic thing on there. You're not going to be able to edit it. You're not going to be able to drag and drop your own MP3s, all that stuff on there. If your kid breaks it, you can just print a new part for it. So I think it's going to be super cool to have a sweet identity disc. So
yeah, I'll back up a little bit and be like, in the United States, Disney World and maybe Disneyland is having a Tron ride. It was only exclusive to the Shanghai Disney park, but now it's coming to the Americas, which is fantastic. It's just opened for exclusive for pass holders and cast members, and soon we think in April, right? Or in March?
Yeah, we get the email tomorrow to get our reservations. Hopefully we get something in the afternoon so we can get all those cool light ambiances going on. Future looks
it's so a super cool roller coaster ride that uses it's just a fantastic looking building showcase. It's kind of like outside. It's in the future world area of the Magic Kingdom, part of Disney World. It's really bringing the Tron franchise back to life. I think it wasn't dead before, but it's just in the zeitgeist right now. It's in the psyche right now. So
yeah, one of the things that we were watching was saying that the movies didn't do good, but this works really well as an actual themed land. So there's that.
Yeah, right.
And then of course
Tron
the
Land.
Daft
That'd be
Punk
great.
soundtrack going throughout the land.
It's incredible.
It's so freaking cool. So anyway, light their Tron disc, identity disc, whatever. If you go over to where am I? I'm all lost. Yeah,
you're right there.
Here. So what I'm basing this off of is I already made something that was kind of similar. It was this LED chase game. So exact same shape. The diameter, I think I'm going to leave the same. The only thing that's going to change, obviously, is all the cool stuff on the inside, which looks like, instead of having just the LEDs on the side, we have to have them pointing up and pointing down. So I'm going to use the side lit mini Neo pixel strips. So I'm going to be pointing up, and then a regular mini skinny NeoPixels that are pointing outwards. So I'll have the light shooting up and one shooting out to the side. I'll have the battery that mounts. We'll have the 2200 milliamp. It has the clip on there. And then we'll have the magnet mounts on the side here, so that it'll attach to something you're gonna have to, like a harness or something you have to wear underneath your shirt or something. Your slide switch on the side there, and did that finish printing? No, it's still printing. Want to go grab it and show. We're doing the color swap. So on the first layer, we're doing the diffused white, so that'll shine right through, and then the black after that, and then another layer of the white. So we'll have those the way that the lights shine through. I didn't want to have like different parts that snap together or have to glue anything. So super easy way to accomplish this is just swap out the colors if it's simple on the Z that you want your colors to change. That works perfectly.
Nice. That is a good technique. Instead of having to glue parts together, you just swap it out if it makes sense.
Yeah, I mean, if you have like a dual extruder, you could do that, but I want to make it accessible for everyone. And if you're running Octoprint or something similar, you're going to have the pause layer for this case, it's like layer 12 and layer 123 is where I'm pausing to change out the filament for that, and that works really good. So
cool.
That is what I'm prototyping. It's going to be using the Feather RP2040 and the Prop Maker wing, and that's what it looks like so far. So hopefully have a nice working prototype. Hopefully before we have to go and ride it, because I definitely want to get some cool hero shots while we're there. I don't know if they let you in to like the Tron area until you have like access. So yeah, super sweet. Interesting. Some shots in there. And I ordered some like costumes for Declan. Oh, look, it finished. What? Should I go pull it off the bed and see what it looks like?
No, you gotta wait for the bed to cool down. Well, I can show off my prototype while it cools down. You can go grab it.
Okay, yeah. So and I actually have your prototype as well, so we can show.
Yeah. I have it here on the overhead.
Yeah, a really good discussion on orientation of your print.
Oh, yeah. So this is going to be a collab project with Amberella, who's on the team, and she is working on some CircuitPython code that will display your CircuitPython drive visually. Here, let me hide myself. There. Oh boy. There we go. Now I can add you in there. All right, we just gotta like swap it until it like works right. Yeah. So this is a floppy disk. It's the 3.5 inch version. This is an actual floppy disk, and so the idea was that Anne wanted to take the shape of the iconic floppy disk and then put a PyPortal screen here in the label, and that way she can display icons of her of the files that are on the CircuitPython drive, and it's using Adafruit PyPortal. So this is what I came up with. It's a little bit chunky, reminiscent to maybe a zip disk, but it's not too much bigger than your floppy. Let me see if I can get a better shot here. There we go. So this is the Adafruit PyPortal. It's got a 320 by 240 screen. I got some details here, like the arrow, the HD thing there, and then I kind of have these countersunk screws here. It's using support material because it's just kind of the way to get that shape here, where it has like this indentation here at the bottom. And then I have this little bit here that that kind of comes out. I don't have an actual disc in there, but I thought it'd be interesting to kind of print this as a separate piece instead of having to use like tape or glue or something. And then it just kind of clicks in and then slides in there. And then on the back, I have some more details here, just kind of that imprint, the imprint of the label. This little disc here thing that's on the back there, that's the thing that would actually have the motor drive the disc and spin it. And then I actually have a button presser here. So this allows you to reset You have the LED here and a NeoPixel there. I have them shut off for this piece of code, but for now I'm just displaying a bitmap image of this week's Timelapse Tuesday. Yesterday was Valentine's Day, and this is a very fun kind of helical heart designed by DaveMakesStuff. Yeah, and then you got your connection here for micro USB, micro B. Sorry, it's not C. And then you have a little notch here for the micro SD card, so you can have external storage here. And I guess I could take it apart. Why not? Let me disconnect this real quick and show you that it is a snap fit case, so I can get my fingers in there. There's the Adafruit PyPortal. There's my snap fit bit here. Yeah, it's just kind of a fun case design for your PyPortal in the shape of an iconic save icon. Yeah, right.
I think that's what the kids call it.
Yeah, that's what the kids call it. It's save icon. Although I don't know if the save icon is a disk anymore. It's more of just like the down arrow these days. But you can see here that the support material that I used, I actually had to use an interface layer. And Pedro, you can queue up the video if you'd like and show something about it, or we can wait till next week. I think this is in 2 weeks. To have this as a learn guide, and we'll probably do a video as well. But yeah, that is what I got going on. It's a floppy snap fit case for the Adafruit PyPortal.
Yeah, no, I think we have time. The only thing we want to talk about was orientating the part so that the slicer prints a certain way. I was trying to do all this trickery inside of the top and bottom layers where you could tell it to print at a certain degree, like 45 degrees or 90 degrees. So what we're trying to do is so it's printing, vertically up and down instead of making a zigzag shape. So no matter what settings that I was putting in there, it just was not paying attention to me. So the solution that Noah came up with was just simply rotating the model to 45 degrees. The reason why I was trying to avoid that was, what if I have something that's the size of, the full bed and I can't rotate it? That's going to suck. So it's like, crap. It's got to be like a bug inside of Cura or something. So just be aware of that. It does not pay attention when you tell it to print at a certain degree. It just ignores you. It actually switches back. If you notice in the settings, like once you're done slicing, it like switches it back to the 2 brackets, which I think is just a Boolean, depending on how the layout is. So
this project is like showing me how using support material is like an art form in itself. There's a lot of little tricks and things to look out for. And I'm learning more about it. And normally I try to stay away from support material, but something like this, you kind of can't really do that. It's unavoidable. Yeah, you really want to have this to be a unified piece instead of breaking everything apart and then gluing everything later. It just makes sense to have this kind of geometry be supported by support material and an interface layer so that it has that canopy to kind of catch itself onto.
Yeah, the photo that you sent me of the ones that were fusing, were you using the Z distance for the supports?
Yeah. Oh yeah, I was. One of the things I realized, like for these, let me see if I can do a different.
What is the distance that you're using for it?
I think 0.2 or 0.3, something like that.
I'm using 0.21. That 0.01 makes a difference, and I'll show you in this video when you're done.
Really?
Explaining that. Oh yeah.
Sometimes like with this little piece here, like I ended up just adding a chamfer to the hole instead of adding support material here, because like the perimeters are so close to each other that it ends up catching itself. So it's kind of hard to get this in the camera, but like that little detail there, anytime I would add support material, it would just fuse to those outer perimeters. So just don't put any support material there, and your perimeters will kind of catch if you have a chamfer, because it's kind of slowly, gradually, layer by layer, adding material and kind of shifting it over until it catches itself. So I ended up just not having support there, and it doesn't look too bad there, because like you're trying to replicate this kind of a fine detail there, where it's perfectly fine in CNCing and injection molding, but when you're doing 3D printing, you don't even need any supports in that case. But you can see here how it's still not 100% clean. But hey, that's kind of the trade-off you have with the additive manufacturing. So yeah, and then on this case, like you can see, like this I didn't need to indent. It's just kind of flush with this layer, but just have that little groove there. You can almost make out how it just catches itself there. So it ends up working okay. Same thing with these. Like I just printed this upside down, and it looks kind of grimy on the inside, but it looks fine because like I wanted this layer to have that texture from the bed because it's using a PEI textured bed. It doesn't look too bad. So yeah, just some things to consider when using support material and designing, for 3D printing. So there you go.
Then I just wanted to show when you have the support materials optimized so good. Where is it? There it is.
Oh wow! Just
pull it off, and the support materials stay on the bed.
That's great. That's like
because of the
winning a maker lottery.
Yeah, it's 0.01. Oh, and then goes right into the other thing I'm prototyping. We're going to show off .star support inside of WhipperSnapper. So I'm just showing adding one of the block elements right on your phone so you can have that control. Some in addition to
NeoPixel, I almost said NeoPixels.
.stars in this. Well, no, NeoPixels are supported as well. .stars also. That's the thing I'm showing off there. So in addition to your humidity, temperature, your the VOCs, volatile non-organic compounds, your CO2, your light levels, all that stuff you can now control to based on any one of those things. So what I'm going to do is base it on when the sun rises or when it sets to have it timed to turn off at a certain time.
Very cool. And then straight into the you got three things going on. That's great. A lot of prototyping this week. All right.
And that's what we're prototyping. Let me get this out. Remove. There we go. And good morning. Where are you now? Oh,
it's fine. We're going to take some questions now for kind of shop talk. We got one from Anthony on the YouTube. It's asking if you could do some loops, like some GIF animations using the Feather TFT. And that is a great question. Let me load up our Learn Guide for running GIFs. And you have two options to do it. The first option is with Arduino. So we have this guide here that we did a couple months ago. It is the mini GIF player. And this uses Arduino. Does it use CircuitPython? Oh my god, it does use CircuitPython.
It uses CircuitPython to load to mount the
drive.
disk, the drive to drag your GIFs on there, but then it's using Arduino to actually
process the GIF.
Yeah.
So this is a great piece of code.
A little bit of some puzzles you gotta stick together.
It can definitely be. It works. You'll just want to, when you're running the code on the TFT Feather, you'll just want to make sure that you have all your libraries installed, you have your board profile installed, and then you'll want to modify the TFT pinouts so that they're the correct pinouts. You can use the TFT guide, the Learn Guide, the product Learn Guide, to find out exactly what the Arduino pins are for talking to the display. And then over here, you want to make sure that your GIF, your width and your height of your display is different. It's not going to be 320 by 174. It's going to be whatever the TFT, the resolution on that is. And then here you can kind of just read through the comments, and then you can kind of either you want to resize your GIF or have it displayed as is. You can kind of do that. The code's a little gruesome for my taste. But if you have a little bit of software experience, you might be able to kind of read through it and just kind of make sure that you're hitting the right pins. That's really the main thing, and that you have your libraries installed. But you should definitely be able to update this piece of code to run with GIFs on the reverse TFT. Now, another kind of cutting edge of CircuitPython, our community member Mark Gambler is working on getting native GIF support on CircuitPython and only CircuitPython. So check out either the Discord or Mark Gambler's GitHub repo. maybe we'll share some links in the Discord later. But yeah, that is some cutting edge stuff. I also saw that Tim Foamy Guy did a live stream either this week or last week. I think last week he did one on testing out that library and that code base for CircuitPython. Next question from Anthony again. He's asking about the Reverse TFT SD card.
Yeah, that's what that's what he's referring to, actually, to get the GIF player on there. And I would say, yeah, Mark Gambler, I think his should be okay because he was showing it off on a matrix display.
Oh, right. Yeah, that's right. Yeah. Yeah, that's what's awesome about CircuitPython is you can kind of display graphics on a number of different style of displays. E-ink, TFT, what's the other one? the matrix stuff, the RGB matrix displays. Yeah. Yeah. Ian is also excited for CircuitPython GIF play. We all are. We've been waiting for it. And
before I let it slip my mind again, the other difficult part about this is going to be optimizing your GIFs, because you can't have like a 5 gigabyte or whatever giant
5 megabyte
it has to be sized exactly to your screen, and some of these have like funky screen resolutions, like 251. It's like, oh
yeah,
135 pixel in there. It's not gonna work at all. So definitely if you're using that older code that we were talking about.
Yes. Yeah. It's a 240 by 135. This display. It's a little bit peculiar, but yeah, that's just what it is. So yeah, this is the learn guide for the Reverse TFT, by the way. So if you want to look out the pinouts and find out exactly how the which pins are being used for the display, you can find that all here in this lovely diagram. Here you can see the display has its own set of pins, and you can talk to them either through the Arduino, using Arduino GPIO names or the CircuitPython names, which is all there for you. So check it out.
Very cool.
Okay. Very good. Very good.
Can't wait either. Be another cool little GIF player.
Okay. Are we community making next?
Let us see. All right, let's jump into community makes.
Okay. Community makes. We have a time lapse that we do every Tuesday.
This Tuesday was not just Taco Tuesday, but
Taco Tuesday. Hold on. There we go. Wait, it didn't work.
So there's a really cool Helix puzzle heart from DaveMakesStuff, and hidden on the inside. Hidden on the inside is a little compartment, so you can have a little ring inside there, or whatever, I guess. But I'm guessing ring. So super cool little like folds onto itself, and there you go. So I'm using I think it's the mermaid blue and just a regular pink PLA. A couple of supports were used. Oh, wow. You can kind of see. I know. It's clean there. I think where is it? Oh, here it is. It's printed like that, straight up vertically, and it did a really good job of having everything nice in terms of the tolerances. Everything fits very well. I did add a couple of drops of real butter just so it could be nice and smooth when pressing the two parts together. Where did my other part go? It fell on the floor. There it is.
It flew.
And yeah,
flew across the room.
So it goes on like that, and then also it can twist all the way down too past that part. So there's no like end stop for it. And yeah, very awesome design. I think he said he was using N topology to do the modeling for this. So definitely check it out. Like how smooth and it's the nice compact size for doing a little proposal or something, and the compartment is big enough to fit like bigger rings too. So you have like like a size. I forget what ring sizes are. So the bigger rings should fit perfectly inside there.
Cool. The STL model is available to download off of the Thangs website. We have it listed in the description of the video. But yeah, DaveMakesStuff has this stuff up here too. Oh, did he? Okay.
Yeah, it's everywhere. In all of the repositories.
Okay. Well, this is a 3D model of it. Like you said, support material. And yeah. Get it ready for next Valentine's Day.
I mean, there's
That's a
yeah.
Blizzard Day.
I
That's
mean,
fun.
proposals happen all the time, so whatever day.
Right. You're right. It's not just exclusive to one day of the year.
For
All
us,
right.
Valentine's great. The kids got more chocolates and candy day. Perfect. That's how we see Valentine's Day.
Oh, really? Okay.
Like,
all right.
great. There's
Well,
cards and stuff all over the place. There's candy everywhere. We got to take away from them.
all right. Next up, we're going to speed round this. Pedro, we have 5 minutes and we have over 18 makes. So let's run through them now.
Oh my God. Don't do all 15. You have to chop
I
up
kind of.
again.
All right. 1, 2, 3, 4, 5, 6, 7, 8. All right. This will be next week here. All right. I chopped them up. So we're going to do like 10 this week and 10 next week. So I have here is a post by Jonathan Heyman. He posted up a make of the Kingdom Hearts Keyblade. It's a prop, 3D printed prop. No electronics, just parts that screw and snap fit together. You can print it in various filaments, and you don't really need to do many post-processing. So Jonathan posted this up, and it looks fantastic. Look at that shiny kind of silver-colored PLA filament. Looks fantastic. And that's posted up on the Printables website, so you can check that out. Next up, we have a Promo Proto feather case posted up by Bud on Printables. So they're working on this is a really good use of the half-size Promo Proto. It's got various components on it. Looks like some sort of SparkFun micro on there. Looking very, very cool. And it snap fits. It has a bottom that snap fits the Perma Proto, and it has like a bit of a case with some portholes and stuff. And it has mounting tabs along the bottom there, so you can mount it to all sorts of different surfaces. Very, very nice. Next up, we have one. I think this one is from DJ Devin. Treasure Dev posted up his make of the IoT mailbox. So he printed this up in this black filament with some nice shiny blue. Looks really, really fun. It's got a micro servo in there to make the flag, the flag of the mailbox go up and down when it receives certain messages. Doing an upcoming LoRa and MQTT project. Using the magnetic cable for easy attachment to the back. Redesign the flag so it has super gluing. The servo arm is no longer necessary. Used a butane torch on the flag collet for a second pass and press fits onto the end of the metal servo gear. Oh, that's an interesting way to do it. And he specifically chose the servo with a metal gear for this reason. Yeah, that's a good tips there from DJ Devin. All right, next up, this is a really fantastic make because it's in video format. This is from Sean Hetzelman, who works at Microsoft. And Sean made the Dark Saber. Are you seeing this, Pedro?
Yes.
Yeah, you're seeing
so
this. Is fantastic. A very, very excellent video as well.
This is why we do this. Seeing you know how giddy he gets when it's all starts working, and then when it's all finished, dude. This is why we do this.
Yeah, so he's using the Feather NRF52840, which is that Bluetooth board. It's running CircuitPython and the prop maker Featherwing. So he has the accelerometer, NeoPixel support, all the things that you need to make a light and sound prop. He 3D printed the blade in those various parts and glued them together. He actually asked you before he finished it, like, what's a good technique and what's a good glue? You helped him out get some accelerator and the right type of Starbond super glue that we really like and recommend. But he followed the learn guide and he got it working, and it runs really well. So very, very cool. Shout out to Scott for yeah, right. It's always nursing. And there's the circuit diagram.
That you can follow the guides we write. It's like, oh no, is it gonna work? Come on, please. Because when libraries upgrade and things break over time, it's like, oh my god, come on, please work. Or like
it's great to see that
die or something.
No,
Chips,
but it all worked out
canes.
well. Yeah, totally. Very, very cool. So big shout out to Scott. Okay, and we got more. We got some more. We're running overtime now. We got a emerald, a snap fit emerald, inspired by the Sonic the Hedgehog movie. This was posted up by John D65. He printed up the emerald in this lovely kind of, let's say, copper color. It's kind of shiny, I think. So that's very nice. And that was posted up on Printables. And you put a space here, so maybe we break there, and we
That's
save.
it, man. It's 12.
Yeah, I'm gonna say that's
I'm
it.
hungry.
I know you are. I'm gonna update my notes so that this is next week and this was this week. Shout out to everybody for posting up their make. We know it's
I didn't rip the thing off.
what thing?
The identity disk. Let me quickly go to that.
We need
live. Where am I? Yeah, there I am.
You're right here. There you are.
Let me go rip it off.
All right, I'll talk amongst myself. I think I have a question I might answer here. Let me see if I can scroll up. We got a question from Anthony. How does the Feather do with enclosure and heat? I'm trying to use this in a pocketable setting, so it's very closed. I'm concerned about heat. Yeah, so you really don't need to concern yourself with heat too much, as the PCB is rated for very extreme temperatures, so it should be fine. Yeah, I don't have any specific values of what the heat is, but you should be able to run it for several hours, and it should be fine. I was just answering a question from Anthony.
Yeah, the board should be fine. It's not going to melt on you because I think Lamar said it can withstand like 2 something C, like, or it's going to be uncomfortable. You're not going to want it in your pocket, but for you, it might be a little too hot. It can. There it is. Get the light shining through, and this is again swapping out the filament, so it goes from the translucent to the black. So we'll have it on the sides, shining through, and then on the top there.
Cool.
Wow. Yourself. So that should be so cool. On the back.
Wow. Yeah. Oh, okay. Yeah. That's a good size.
The pose the photo pass cast members make you do when you're taking your photo with it. Yeah. Should be cool. All right, cool. Let's get off. I want to assemble this thing already.
All right, and get yourself some food. All right, well, if folks want to get any of the parts or get any things to make your props, definitely use the coupon code for today. It's TFT Stand. We'll have another one tonight. Tonight is 2 shows. At 7:30 is the show and tell. So that's going to be hosted by Mr. and Mrs. Lady Ada at 7:30 p.m. Eastern Time. And then Ask an Engineer shortly after at 8 p.m. Eastern Time. Full hour plus of open source hardware, top secret, INMPI, and much more. So check that out. We also have John's workshop tomorrow. JP's workshop is on at 4 p.m. Eastern Time. Same channels here. Phone me guys on Friday, 2 p.m. Pacific Time or 5 p.m. Eastern. And then from the Dusk of Late 8s on Sundays. We got a full list of shows, of course. You can go to the Discord chat room and do the pin. There's a pinned post there. So you can find out all the show times, or you can do !show times, and you'll get a list from our chat bot that tells you what the list of all the shows are. Thank you, everybody, for hanging out. And thank you, everybody, for watching on the archive, for tuning in. Good luck with all of your maker endeavors. We will see you tonight on Show and Tell. So we hope to see your projects and yourself, of course.
Don't forget to make a great day.
Bye, folks.
Bye-bye.